Over the years, people have said to me something like, "You're a scientist, how come you believe in God?" The shorter answer is, it is precisely because I'm a scientist that I believe in God. Let me explain. We'll just dim the lights now so that you can see what we're going to put up on the screen. Among the first things that students learn when studying about science are the laws of conservation. Fancy words that mean, firstly, matter cannot be created or destroyed, and secondly, energy cannot be created or destroyed. In other words, there's always the same amount of matter and the same amount of energy, even though energy may be changed or converted from one form to another. For example, when we make electricity, the chemical energy stored in the coal is converted into heat when the coal is burnt. The heat is used to boil water and make high-pressure steam. The potential energy stored in the steam is then converted into mechanical energy in a turbine, and this mechanical energy is converted into electrical energy in a generator. The electrical energy or electricity travels along wires to where it is used in some device to do useful things. Unfortunately, not all of the energy stored in the coal is available for use in the final device. At every stage of the process, energy is wasted. It leaks into the surroundings as heat energy. If we could measure all the energy made use of and all the energy wasted, we would find that it equaled the amount of energy stored in the coal. None has been created and none destroyed. Likewise, the carbon in the coal has burned by combining with oxygen in the atmosphere, forming carbon dioxide. If we could measure the amount of carbon burned and the amount of oxygen consumed, and if we could measure the amount of carbon dioxide produced, we would find that the amount of carbon dioxide is exactly equal to the amount of carbon plus the amount of oxygen. There has been no creation or destruction of matter. Scientists have done lots of these kinds of experiments and have proved these things to be so. However, Einstein came along with his special theory of relativity and his famous formula E equals mc squared. This showed the equivalence of matter and energy. The atomic bomb and the hydrogen bomb have since shown that indeed matter can be converted into energy. Under these conditions, the two laws of conservation become one. Matter-energy cannot be created or destroyed. This law is basic. One could even say common sense. Now, when we look around at the world around us, and particularly at the universe above us, we are curious. And the scientist is curious. And we ask, how can these things be? Where did they come from? What is their cause? For many years, scientists were happy to believe that it had always been that way, at least as far as the universe is concerned. However, Edwin Hubble, after whom the Space Telescope was named, put the cat among the pigeons. It happened this way. You see, for many years, scientists thought that the Milky Way, of which our solar system is a part, is the only really large collection of stars in the universe. But as telescopes became stronger and bigger and more powerful, it was eventually found that individual stars could be seen in what is now called the Andromeda Galaxy. Careful measurements showed that it was a galaxy similar to our own Milky Way galaxy, made up of billions of stars. It was soon realised that there were millions of other similar galaxies further away. Hubble was interested to see if these galaxies were moving toward us or away from us. Now, it had been found possible to measure the velocity of individual nearby stars. Some are getting closer and others are further away. As well as this, there is a sideways movement, which can be seen by comparing photographs taken years apart. Movement toward us or away from us cannot be seen in that way. Instead, the rainbow spectrum of each star is examined. The rainbow spectrum of the Sun shows a number of dark lines. They are caused by various elements at the Sun's surface. The two dark lines in the yellow here are due to sodium. Stars have similar dark lines in their spectra. The lines in these spectra are moved slightly to the blue or slightly to the red end of the spectrum, depending on whether the stars are moving toward us or away from us. This is similar to the way that the sound of a car horn changes pitch as the car goes by us. Around 1912, the movement of galaxies was first measured the same way, using the dark lines in their spectra. The Andromeda Galaxy was found to be hurtling toward us at the crazy speed of 300 kilometres a second. A number of other galaxies were found to be moving away from us. In 1929, Hubble showed that on average, the more distant a galaxy is, the faster it is moving away from us. Here we see Hubble's own graph. The Andromeda Galaxy is down here moving toward us. The others are all moving above the zero line, moving away from us. Here is another graph made in 1996, confirming what is now known as Hubble's law, which states that the velocity with which a galaxy is receding from us is proportional to its distance from us. We're going to come back to that picture again further down the lecture tonight. Now, the fact that the galaxies are moving away from us, and the further away they are, the faster they're moving away, shows that the universe is expanding. Now, that is all very well, but what would happen if we were to wind back the clock? The galaxies would start to come together, and if we were to wind the clock back far enough, the galaxies would all be in the same place, billions of them. And this led scientists to propose what is now known, and you would have heard it, called the Big Bang theory of the origin of the universe. Put crudely, this meant that there was a Big Bang which created all the galaxies and sent them flying in every direction. And it all happened about 14 billion years ago, according to their calculations. However, scientists who reject the idea of the intervention of God are left with massive problems on their hands. Firstly, how can anything come out of nothing? Here we have an extremely large amount of something, the whole substance of the universe in fact, coming out of nothing in an instant of time. It defies the laws of conservation that we mentioned at the beginning. Scientists realise this and are still puzzling over it. As recently as 1998, J.R. Gott wrote an article in Physical Review entitled, "Can the Universe Create Itself?" In this 43-page, very mathematical paper, he has proposed that the laws of physics may allow the universe to be its own mother. He was even prepared to consider the action of advanced civilizations as having a part in the process. Not surprisingly, his views have not been widely accepted in the scientific community. Now, I'm aware that some scientists claim that gravitational energy, which is negative, exactly cancels out the mass energy of the fledgling universe, and that therefore a Big Bang is possible without additional energy input. However, this is not feasible. And I'll show you why. Scientists frequently have to deal with very large numbers or very small numbers, and so a kind of shorthand has been invented to deal with this. Now, you all know that 1,000,000 is written as 1 followed by 6 zeros, and in the shorthand form this is written as 10 to the power 6, the 6 indicating that there are 6 zeros. Likewise, 1,000,000,000 has 9 zeros, and in the shorthand it's written as 10 to the power 9. Using this system we can write very large numbers with, say, for instance, 58 zeros without having to count all the zeros, which is big help. On the other hand, we may want to deal with a very small number, say 1,000,000, which is 1 over 1,000,000. This is written in the shorthand notation as 10 to the minus 6th power. The minus sign indicates that the 6 zeros are in the denominator, on the bottom of the fraction. Thus, we could have a number, say 10 to the minus 6th power, which would have 63 zeros in the denominator, an extremely small number indeed. And with that information, we're now ready to consider the effect of gravity. Could gravitational energy cancel the mass energy of the baby universe to enable it to get started? To find an answer to this question, we will consider 2 neutrons. They would have to come within the incredibly short distance of 6 times 10 to the minus 53 centimetres. That number has 53 zeros in the bottom of the fraction. They would have to come within that distance before their gravitational energy would cancel their mass energy. But the diameter of a neutron is much greater than this. It's only 10 to the minus 13 centimetres, only 13 zeros on the bottom. One neutron would have to be completely inside the other neutron, if that were possible. The problem is that once inside the neutron, the inverse square law of gravity on which the above calculation was made no longer holds. gravity drops off to zero at the centre. Hence, gravity could never get anywhere near cancelling out the mass energy of the neutron, or, for that matter, any other subatomic particle. It amazes me the lengths that some scientists will go to eliminate God from their reckoning. Yet, God is the only possible source of the hugely massive amount of energy required to get the Big Bang started, if it really was at the Big Bang that formed the universe that we see. Yet, even if that hurdle could be jumped over, even if the Big Bang could get started by natural means, we are still not out of the woods. In order for the Big Bang to be able to produce the stable, long-lived, expanding universe that we now see, several massive fudge factors have to be introduced. The first of these is what is called inflation. This has to be introduced to get the universe expanding. Energy itself is not sufficient to do it quickly enough. So inflation and the hypothetical inflaton particles were introduced into the picture to get the baby universe expanding. Inflation is said to have started 10 to the minus 36 seconds after the start of the Big Bang, and to have continued up to 10 to the minus 32 seconds. During this incredibly short time period, the volume of the universe is said to have increased by a factor of, wait for it, 10 to the 78 times. There are 78 zeros in that number. Quite a large fudge factor, I would say. The so-called dark matter needs mentioning at this point. No one knows at this time just what this dark matter is, if it exists at all, for it is transparent and invisible. But current scientific opinion holds that there is lots of it, roughly 6 times the amount of matter in all the stars and galaxies that we can see. The reason scientists have come to believe in large amounts of dark matter is that without it, most of the galaxies would fly apart. They are rotating too quickly. Something other than the normal gravity of the stars is holding the galaxies together. So, although they have never seen it and don't know what it is, scientists believe that it is the gravity caused by lots of dark matter which is holding each galaxy together. Is it really dark matter, or is it the hand of God? We wait with interest as scientists scramble to try and detect this elusive dark matter so that they can work out what it is, if it exists at all. But the introduction of all this extra dark matter created a new problem. Prior to the idea of dark matter, it was thought that the average density of the universe was somewhere near the critical density. By this it was meant that the expansion of the universe would get slower and slower, but never quite stop. Anything greater than the critical density and the gravitational attraction of the galaxies for each other would slow the rate of expansion of the universe and turn it around so that it would start collapsing and end up in a big crunch. One would think that with all this extra dark matter, the universe would have collapsed by now, but it obviously hasn't. We are still here. Then in 1998, another bombshell broke. Not only was the universe still expanding, despite the dark matter, but the expansion was actually accelerating, as we see depicted on this graph. The upward curve of the graph here showing the acceleration. This was announced by A. Rees and others in the Astronomical Journal. You may recall that only last week, one of those on the team, Brian Smith, an Australian scientist, received the Nobel Prize for his part in this discovery. In fact, if you look at the graph I showed earlier, you can see that the galaxy right furthest away is above the line here, and you can see the acceleration here on that particular one. Rees and Smith and others measured a number of other galaxies in this region and showed that it wasn't just a matter of error. There really was acceleration going on. To account for the acceleration of the universe, scientists have introduced another hypothetical, dark energy. And according to them, there are massive amounts of it. Roughly 74% of the mass energy of the universe is believed to be dark energy. The other portions, 22% dark matter, and only 0.4% of stars, etc. A certain amount of intergalactic gas there. Dark energy has been called one of the most profound mysteries in all of science. Is it real? Or is God trying to tell us something? Could it be that the power of God is preventing the universe from collapsing into self-destruction? And just to make sure that we take notice, he's added a little bit extra to make it accelerate. The more I consider these things, the more I can agree with the writer of the psalm who said, "The heavens declare the glory of God, and the sky above proclaims his handiwork." Do you have any questions so far? No questions? Okay, we'll continue on. So far, I've shown you some of the difficulties with the Big Bang theory of the origin of the universe. However, there are even greater difficulties that I must now mention. The first is the problem of antimatter. What is antimatter, you may ask? Antimatter consists of particles similar to electrons, protons, and neutrons, but the antimatter particles are the opposite of the electrons, protons, and neutrons. In fact, they are so opposite that when an antimatter particle collides with its opposite, the two particles annihilate each other. Thus, an anti-electron will annihilate with an electron. An anti-proton will annihilate with a proton, etc. Their mass is converted into energy according to Einstein's equation, E equals mc squared. Anti-electrons are also called positrons because they have a positive charge. You know that electrons have a negative charge. They were first discovered in 1932. They occur naturally in some forms of radioactive decay, such as potassium-40. When they annihilate with an electron, the energy is carried away in the form of two gamma-ray photons travelling in opposite directions, as we see here. Antiprotons were first discovered in 1955 by Owen Chamberlain and Emilio Segre. They received the Nobel Prize for this discovery. The antiprotons were formed in a high-energy particle accelerator called a beavatron. They proved that they had produced antiprotons by measuring their charge and their mass, and by capturing pictures of their annihilation with protons. as we see here. That's one of their pictures. What has all this got to do with the Big Bang, you may ask? It has a great deal to do with it. It prevents it from forming the kind of universe that we now see. It had been predicted, and Chamberlain and Segre showed that particles are always produced from energy in pairs. An electron with a positron, a proton with an antiproton. They also showed that these particles are annihilated in pairs, a proton and an antiproton, whenever they get anywhere near each other. This has tremendous implications for the Big Bang theory, and scientists are still puzzling over it. The problem is that for every particle of matter that was formed in the Big Bang, an exactly equal number of antiparticles must have been formed. Within a very short space of time, these would have all annihilated each other, leaving nothing but energy. Yet this is plainly not the case. We are all here. There is plenty of matter and no sign of any significant amount of antimatter anywhere in the universe. It proves that the Big Bang could not possibly have formed the matter of the universe as scientists claim. We find ourselves in the situation where scientists, following the laws of physics backwards from the present day, are led to think that the universe began with the Big Bang. But they are then willing to discard the laws of physics to make the Big Bang possible. Firstly, they discard the laws of conservation, which do not allow something to come out of nothing. And secondly, they discard the laws of particle physics, which do not allow the formation of matter without forming an equal amount of antimatter. A number of scientists, including myself, conclude that this inconsistency is just not on. The only possible alternative is that a being of great power and knowledge, such as the God of the Bible, created the universe we now see. Having shown that the universe could not possibly have come into existence through natural causes, I will now share with you evidence which proves it did not come into existence this way. It has to do with those beautiful celestial objects we call globular clusters of stars. There are at least 158 of these globular clusters associated with our Milky Way galaxy. Some are close enough to be seen with a pair of binoculars, and what a beautiful sight they are. A picture like that will not do them justice. Other galaxies have globular clusters associated with them also. For instance, the Andromeda galaxy has around 500 of them. The globular clusters are situated in a random fashion above and below the disk of the galaxy in what has been called a halo. As well as the globular clusters, there are billions of individual stars in the halo. This halo of stars and globular clusters can be seen most clearly in the Sombrero galaxy. Seen here in visible light, where you've got the halo above and below the disk of the galaxy. Here we see it in infrared light, and it makes very clear the distinction between the stars rotating in the disk of the galaxy and the halo stars above and below. The globular clusters presents scientists with some real problems. The first is their age. The first estimate to the age of the stars making up the globular clusters was that they were 20 to 25 billion years old, as I read in the Scientific American. This made them almost twice as old as the universe itself. This, of course, is not possible, so adjustments have had to be made to the way their ages have been calculated. Nevertheless, they are still regarded as the first objects to appear in the universe, and their origin is considered a mystery. But that is not all. It is obvious from their perfectly spherical shape that globular clusters have no overall rotational movement. Individual stars in the globular cluster must move in orbits around the centre, but those orbits must be in random directions so that there is no overall rotation. Similarly, the spherical shape of the galactic halo of stars and globular clusters shows that there is no overall rotation. The globular clusters and halo stars must therefore move in random orbits around the centre of each galaxy. Here is a wonder indeed. Each spiral galaxy shows a pronounced overall rotational movement of the billions of stars that make up its disk, whether seen from above or from the side. Yet associated with each of these rotating disks is a halo of stars and globular clusters which do not have this overall rotational movement. If the billions of galaxies were all formed from a Big Bang, how is it that many of them contain rotational and non-rotational elements in intimate association? A central rotating disk and a non-rotating halo. What could cause the separation of these two classes of objects? It is just not possible. It is clear evidence to me that the universe did not follow from a Big Bang. The only possible conclusion is that God made it the way it is. As it says in Psalm 33 verses 6 and 9, "By the word of the Lord were the heavens made, and all the host of them by the breath of his mouth. For he spake, and it was done. He commanded, and it stood fast." There are many other things that lead me, as a scientist, to believe in God. In fact, the longer time lasts, the more reasons to believe are discovered. Hopefully I'll be able to share some of these with you in future programs. Do any of you have questions relating to tonight's presentation? We'll have the lights on. Thanks, Ray. Yes?
If you've got the, in the middle, swirling around,
Yes.
and if you've got the ones that are not rotating on the outside,
Yes.
well, what's holding that outside bit to be with it?
Well, it is the gravity. Whoops, I meant to press this one. It's the gravity of the large number of stars in the middle of the galaxy, which is holding all these stars in the rotating disk, preventing them from flying out. Plus, it's also holding all the stars and globular clusters in the halo. And these stars and globular clusters are all rotating around the centre in random orbits that don't give any overall rotational movement to the halo. It stays as a smudgy halo there.
Is that the same in our galaxy, the Milky Way?
Pardon?
Is that the same in our galaxy, the Milky Way?
Yes, we have the same sort of thing going on in the Milky Way galaxy. This particular galaxy, the Sombrero galaxy, has a much greater proportion of stars and globular clusters in its halo than any other galaxy that I know of, and thus we can see them much more clearly. They're there present with other galaxies, but because they're much fewer, we don't sort of notice them. Any other questions? Well, thank you for that. Remember to hand in your questions, write them in the book at the back, and I will endeavour to answer them in future programs. Two have already come in, which I will answer in the appropriate programs where they come up. Our next program touches on some of the problems we currently have in the Middle East. What place does Israel have in Bible prophecy today? And what effect is that having on the way Israel is treated by the nations, the major nations in the world today?